Flutter has two ways to do navigation. The original navigation, Navigator 1.0, wasn't very complete, so Flutter introduced a new way to do navigation, Navigator 2.0, and the reception was probably not what they expected. Because of this, there is very little information online about how it works. Even Flutter's documentation barely mentions Navigator 2.0. There are 9 documents about navigation, and Navigator 2.0 is mentioned only once without any explanation of how it works. It seems like Flutter is trying to hide that they ever made this. In this video, we will cover everything you need to know about Navigator 2.0. We will discuss why it was so disliked, how it works, and why I believe you should still use it. When Flutter was originally released in 2018, it had one navigation system. We will refer to this as Navigator 1.0. The core problem Flutter was built to solve is the ability to build natively compiled apps using one codebase for any operating system. While the vision was to be able to support web and desktop applications, in the early days it only supported Android and iOS. Navigator 1.0 was good enough for these two platforms, since mobile applications don't require very complicated navigation. And Navigator 1.0 is simple and easy to use. The core concept to understand in navigation is the navigation stack. As a user, you only see the very top layer of the stack. To see a new page that you can push views onto the stack, and to see the previous page, you can pop views off of the stack. This is the key concept of Navigator 1.0. It still had its flaws like deep linking, nested navigation, and not being declarative like the rest of Flutter. But people were able to look past those flaws and find workarounds. Life was sunshine and rainbows during those times, but then Flutterweb became a focus for the team. Flutterweb brought in even bigger and more noticeable navigation problems, like the URLs not being synced to the navigation stack and the browser back and forward buttons not working. For Flutter to become a true cross-platform framework, navigation would need a complete rework. The biggest shift that needed to happen was that navigation needed to be declarative instead of imperative. The Flutter framework is built to be a declarative framework. That means that the way you write Flutter code is that you describe what the user should see based on a state. Then, the Flutter framework takes care of building the UI based on the declaration. For example, when we want to show a text on the screen, we declare what we want to see, and Flutter just builds it. Whereas in imperative, you have to tell the system to do things step by step. For example, if Flutter were an imperative framework, you would write code like this to display text. Instead of writing what you want to see, you are telling the system what it should do. This is not code that you can write in Flutter. However, some parts of Flutter don't follow the declarative approach, including Navigator 1.0. The widget that handles navigation in Flutter is called Navigator. This can be defined manually, but it is also defined within a material app. The way navigation works in Navigator 1.0 is you find the navigator within your app, using the context, then call a function like push or pop to update the navigation stack. This is very similar to our fake set text example. This approach does not match how the rest of Flutter works. So in Flutter 1.22, a declarative Navigator 2.0 was introduced. We built a boilerplate that uses Navigator 2.0, which we use in all our projects. If you're interested, there is a link below, but let's continue learning about it here. Navigator 2.0 makes navigation declarative. You no longer have functions to push and pop into the navigation stack, but instead you control the navigation stack and define what the stack should look like at any point. Great, problem solved, right? Technically, yes, but then why was it so poorly received? Well, mostly due to its complexity. There are 2 reasons why it was so complex. First, the Flutter team plans to support both Navigator 1.0 and Navigator 2.0, so there are edge cases and caveats needed to make both of them work. And the guides they posted had to explain all those caveats. And second, there were not many guides created to help us understand how it works. That's what we're setting out to do here. Create an in-depth guide to explain Navigator 2.0. Navigator 2.0 introduces 2 main widgets, Page and Router. With Navigator 1.0, we had to push a material page route onto the stack. Now in Navigator 2.0, we define the stack ourselves. The stack consists of a list of page widgets. Then the router widget manipulates this stack. That's the beauty of Navigator 2.0. There's no hidden functionality behind the navigation. It's just a stack of page widgets that you manipulate. In concept, it's straightforward, but as you work with it, you realize how complicated navigation is in general, especially when you need to support both apps and websites. Before we keep going, I want to fully cover what Navigator 1.0 is and how it works. We will only talk about Material App as an example, but there are Cupertino app equivalents for everything. For example, Material Page and Cupertino Page. The Material App widget that you create at the root of your application is doing a lot of things under the hood that make your apps work nicely. One of the things that it does is it creates a navigator for you. You can access this navigator in your application using the build context. The navigator internally creates a list of routes. You can add to this list of routes using the push method, and you can remove routes using the pop method. If you look at the widget that we're pushing, it's a route called Material Page Route. Next, we move on to the Pages API. A page is basically that underlying route that is being maintained by the navigator. So instead of only being able to push and pop, you set the routes directly. You can set them directly within the navigator, and these will be the routes that your app has. This code will start your application with a navigation stack of 3 widgets. Then you can use the same navigator to pop the pages or to push new pages onto it. If you are building a simple mobile app, this might be all that you need. You can manage the pages using state management, and you would have a declarative way to manage your navigation with full control over the navigation stack. The main things you would miss are more apparent when working with the web. Deep linking and syncing browser URLs. Deep linking might also be important for other platforms, of course. This is the part where it gets a little complicated, but it's not Flutter's fault. It's mostly due to all the little nuances that come with browsers. With Navigator 1.0, we had a Navigator widget that would handle the navigation within your app. We still have that same Navigator widget, however it is defined within the router widget. You can declare the router yourself like this, or in a similar way that Material App contains a navigator, a Material App.router contains a router. There are 2 parts that a router needs to have full web functionality: router delegate and route information parser. In the Pages API example, we showed how you can set the pages directly in a navigator. When you use a router, you do the same thing just within the build method of the router delegate. Now the complexity comes in when you have to manage these pages. When you use a browser, the routing information is the URL. How do you transform the URL into a page and vice versa? To start, we need a state variable to be the source of truth for our navigation stack, and somewhere to define what is a valid path or not. For demo purposes, we will use strings, which will be the URLs, as our state object and source of truth. This will help keep things simple. First, we need to define all our valid routes and include a route that we send all unknown routes to, in this case a 404 route. Then, we need to maintain a state for the current navigation stack. You can use any state management approach that you choose, but we will use value notifier with the MVVM architecture that we teach in the Best Flutter course. This value notifier will be the source of truth for our navigation stack, and this will be the only place where this navigation stack can get manipulated. We initialize the stack with our home route, which for most apps should be a backslash, and we will implement 3 methods: push, pop, and replace all. I named these functions push and pop because they still represent what is happening to the navigation stack. By using these function names, the root service is now imperative to make it easy to use in our app, but the logic within is still declarative. Remember, the navigation is just a list, so you can have any functions you want. You are not limited to push and pop, and you can call them anything and do anything with them, like remove only the 3rd page or add 100 random pages in the middle. At this point, we have the navigation stack defined and functions to manipulate it. Now, we need to create our page widgets from this and pass them into the navigator within the router delegate. To do this, we will need access to the service. You can do this using whatever dependency injection you want. We will use a custom-built locator that is similar to getIt package. Then you build the list of pages based on the current navigation stack and pass it into the navigator. We also need our router delegate to listen to any updates in the navigation stack. You will notice there are a few overrides that need to be implemented when using the router delegate. 2 of those are add listener and remove listener. The add listener function allows us to listen to navigation stack changes and update our routes, and the remove listener will stop listening once this router is no longer used. Now you can push and pop onto the stack within your application. But only the push and pop methods from the router service will work. the Navigator 1.0 pop method will not work. This is not necessarily a problem, but the default back button widget calls the original Navigator pop method. You can still catch this using the onDidRemove page method in the Navigator. Same thing with the browser back button. If either of those is pressed, this onDidRemove page callback will be triggered and you can update your navigation stack to match. The onDidRemove page handles the back button within the application and the back button in the browser, but the system back buttons on iOS and Android are handled by the pop root override within the router delegate. When the back button is triggered, we don't want to remove it from our stack directly in the pop root function. If we did that, it would remove our top route, which would trigger the onDidRemove page, which would remove another route. Yeah, I know. Instead, if we just trigger the pop with the Navigator directly, we ensure that only the Navigator can do the pop. But we only want to do this if our navigation stack has more than one item in the list, because when we click the system back button on the root page, we want to pop out of the app, not handle it within our app. We let the device know that we didn't handle the back button by returning false. If we do handle it, like in most cases, we should return a true. We wrap these returns in a synchronous future because it's slightly more performant. There is one more override that we must handle in the router delegate called setNewRoutePath. This function is called whenever the operating system pushes a new route to our application. The most common case of this would be when someone types a URL directly in the address bar. In this case, we want to use our replaceAll function to create a new stack. At this point, the app should function as expected, at least on Android and iOS. If you check the web, you will notice a big issue. The URLs don't work. There's one more key part that's missing for a complete navigation system on all platforms, and that's syncing the URL in the browser to the navigation state. Two main behaviors need to work. First, when you type a URL in the browser, it should go to that page within the app. And second, when you navigate to a page within the app, it should update the URL. To do this, you will need a route information parser. The route information parser is responsible for handling both of the above behaviors, and it does so using two functions. The parse route information function handles the path where a user types in a new URL or uses a deep link. The goal of this function is to convert the URL into the state that we use for navigation. In our case, the state is a string, hence the return type, and it needs to be one of the user-defined routes. I wrote a helper function called findMatchingRoutePattern that looks through available routes and returns the string value if it's there, or returns a 404 if it's not. Once this is parsed, the setNewRoutePath that we defined in the router delegate is called to replace the stack with this new state. The restore route information handles the other case, where some action was taken within the application that requires the URL to be updated. For this to work, we will need another override in the router delegate called currentConfiguration. This gets triggered whenever the routing changes within the application. The configuration returns a string type since that's the state type of our current route. This configuration is then used to update the URL. Now we have a complete navigation system using Navigator 2.0, which is synchronized with the URL. Everything we have covered so far is the fundamental logic of Navigator 2.0. I want to quickly summarize all of it before covering a few more topics. Navigator 2.0 is a declarative implementation of navigation in Flutter. This means that your navigation stack is defined by you. The navigation stack is a state containing a list of data that defines your routes. The list type is defined by you, we use strings in our example, and you are in charge of manipulating that list. The router delegate is in charge of listening to changes in this list and building the routes, also known as page widgets, to be displayed for the user. The router delegate also has functions that notify or give information on route changes. The onDidRemove page function within the Navigator is triggered whenever a page is removed from the stack. The pop route function is triggered whenever the system back button is pressed. The setNewRoutePath function is triggered when a new URL is requested by the system. The currentConfiguration function is triggered when the app routes change. Then the route information parser has two functions to convert from URL to app state and vice versa to keep the system and app synchronized. Everything we have discussed until now has been using static routes, but dynamic routes are a very important piece of the puzzle, especially when working with Flutter Web. The nice thing is that given all the fundamentals we learned, dynamic routes are quite easy. Remember, the navigation system is a list of routes that you define. To have dynamic routes, you need a few helper functions to check for valid paths and extract the information from the URL and vice versa. We based our entire example on strings, which can be good enough with helper functions to extract all the data. But we use a custom route entry class that has a route definition, a builder function, and helper functions to make the whole process easier. Our list of available routes now looks like this. Now, using this as the baseline for your routes, update the router delegate and route information parser to use this data class instead of strings. There are a few issues we ran into that Flutter should have handled better, but since they don't, here they are. We used materialapp.router for this demo, and honestly, it works great. However, you should be aware that there is a new router config property that you can use. It acts the same way, but allows you to define all the router-related things in one place. At the time of this video, the router config has worse defaults than materialapp.router. You have to manually provide a back button dispatcher and a route information provider, while the materialapp.router has nice defaults. Our next tip deals with the URL. In my opinion, having a hashtag in the URL of your website does not look very nice and is not user-friendly. To remove it, import the Flutter Web Plugins package that is part of the Flutter library and call the setURLStrategy function. This will make your URLs look nice, but it will also break your native applications. So you have to use this with a conditional import, so it only gets used if you are running the web platform. At this point, you understand the fundamentals of Navigator 2.0. So should you use it? For me, one thing is very clear. I will not be using Navigator 1.0 anymore. After working with a declarative approach to navigation, it just makes much more sense. Even if I am not building applications with Flutter Web, being able to define my navigation stack feels freeing and opens up possibilities that I wouldn't have considered previously. I enjoy learning about the intricacies of how the native tools work, and I enjoy not having to depend on other people's code. Because of this, I choose to work with Navigator 2.0 directly for my applications. However, it is time-consuming, and there are plenty of edge cases that I am sure to run into as I keep building. For some people, this is not worth the trade-off, especially when there are already tested solutions for declarative navigation. There is GoRouter, which is maintained by Flutter, but in maintenance mode. Then there is AutoRoute and Beamer, which are also widely used. And then there is Navigation Utils, which is a very minimal wrapper. I want to end this video by addressing all the negativity that Navigator 2.0 has received. If anyone from the Flutter team is watching this, here's an outsider's perspective of what went wrong and what could have been done better. It's very clear that navigation is a hard topic, and I can only imagine how difficult even getting to this solution must have been. The biggest complaint the community had was complexity. And yes, declarative navigation that supports both apps and websites was always going to be more complex. But there have been defaults provided since the initial release that reduce this complexity significantly. The biggest complexity seems to come from still supporting Navigator 1.0. After learning about Navigator 2.0, it's very clear that it solves real issues that Navigator 1.0 had, and now Navigator 1.0 seems like unnecessary bloat. Yes, a full transition away from 1.0 would have been annoying, but the end state would have probably been much simpler. And lastly, my biggest complaint is that it doesn't seem like the team tried very hard to educate the community on Navigator 2.0. The reason I was compelled to write this massive video is because of how difficult it was to find any resources explaining Navigator 2.0. In general, the docs are incredible, and I use them to learn so much about Flutter, but the effort when it comes to navigation seems lackluster. At the current state, like 4 years since Nav 2 release, you would not know that Flutter can even support a browser back button or URL syncing from the documentation, and definitely not how to do it. This video covers most of the concepts that you need to know to get started with Navigator 2.0. However, it goes way deeper, and you will need more upgrades as your apps expand. Here are some of the things we've added to our navigation system. A can-pop method to each page. Route definitions containing a builder to make dynamic links simpler. A custom object for our navigation stack containing helper functions and more information about the route. More functions for manipulating the navigation stack. A navigation observer so you can use this with your analytics tooling. And finally, lots of helper functions to clean up the code. You can find the demo code in the description, and if you want to see the full implementation that we use to build production-ready applications, you can find it in our Flutter kit linked below. Here's another video about the MVVM architecture that we use for our navigation system and our apps in general.